The only number you're given is grams nitrogen, so you've got to get it. You've got to start with nitrogen, and you've got to get it into moles. And then you start winding your way through your intermediates to get to CH4. Now this is kind of what it's going to look like, but I've left out the numbers for the mole ratios on purpose for the moment. We use molar mass to get the nitrogen out of grams and into moles. And then substance-wise, we have to go from nitrogen to hydrogen and hydrogen to CH4, because H2 is the common link between those two reactions. You have to relate them indirectly through the coefficients. When we're relating nitrogen to hydrogen, what numbers do we use here as coefficients? 1 for nitrogen, 3 for hydrogen. Good. And when we're relating hydrogen to CH4, what numbers? 4 for hydrogen, 1 for CH4. 4 for hydrogen, 1 for CH4. You cannot mix and match those coefficients. They have to come from the same reaction. Within a set of parentheses, they have to come from the same reaction. So that's what your setup looks like, and then you would do the math. Question?
Even though it says molecules, we don't use everything.
Oh, does it say molecules? Oh, it does say molecules. Oops. Yes, thank you. Is it we starting with molecules? No, we're ending with molecules. Yeah, I'm sorry. I was on a roll with molar mass. I didn't even. I wrote it, but I guess I wasn't paying attention. So what's this last term going to look like instead of molar mass? Avogadro's number. Instead of going moles to grams, we want to go moles to molecules. Thank you. Please correct that. That kind of mistake is minor when I do it. It's not minor when you do it. So always watch your units carefully when you're working these. We're using molar mass and Avogadro's number the same way we always have. The difference is we're applying it to reactions, so the difference is we wind up with these mole ratio terms, which are the coefficients from the balanced equation. Questions with that? All right. Question number 5. We're not going to work this one out right now. This is for you to work later. I want to point something out. It says if 2.83 grams of ammonia are formed, then how much CO2 is also formed? So in that one, it's telling you an amount for ammonia and wanting to know how much CO2 is also going to be produced. And the thing about that is, you've got CO2 in here in two different places, correct? So you're going to have to do two calculations, one of them relating ammonia to this CO2, and that will give you a number. And then you do another calculation from ammonia to this CO2, and you add them up. And whatever the total is, that's a total CO2. It's no different than what we've been doing, except you're going to have to do two calculations and add them up because there's two sources of CO2 in this sequence. But you just calculate each of them independently and then do a total. Question? All right. On Wednesday, we're going to move into reaction types. There's 9 reaction types that we're going to be dealing with. We'll probably get through 5 of them, I would guess, on Wednesday. So between now and Wednesday, work a lot on the kind of things we did today. Limiting reactants, sequential reactions, get those kinds of calculations down well before Wednesday if you can. We are done.